Now we want to look at the limit and continuity, okay? Just continuity part. Just as for the functions of one variable, the calculation limit for function of two variables can be very simplified by the use of property of limits. All right. So, as we know, continuity, examining continuity, we need to use limit as well. But first, let's look at just like the one variable things. All right. If you look at function of f of x equal to x by itself, x by itself, all right. So if your y goes to a and b, well, since it has no y, or you can say the coefficient y is 0, the limit is equal to a. Similarly, if you have a function just y by itself, then if xy goes to a and b, then just y goes to b. Finally, this is a constant functions, right? Constant function, because involving c involving no x nor y, so the limit of constant function equal to constant itself. All right, so continuity. We know that evaluating the continuous function of a single variable is easy. All right, if a function is continuous, you simply plug in the values. So there you go, continuous. Well, similarly, if you have a continuous function on a two variable, then f of xy goes to ab, the function value simply equals to what? The function value at that point. Okay, so as long as f is continuous in the region. So the intuitive meaning of the continuity is that if the point xy changes by a small amount, then it changes very little in the f of xy, because if the function is continuous, right? You change x just a little bit, the function value does not change much. All right, you can say also the surface instead of a line. Now we have a surface, all right? That describe of continuous function has no hole or the break. All right, so following the limits property, you can see that sums, differences, products, and quotients of continuous functions are continuous on their domain. All right, so as usual, the polynomial function of two variables are all continuous. Okay, so for instance, this functions, f of x, y equal to the big mass on the right. All right, if you want to evaluate them, say f of 1, 0, that simply just equals to 1. Since if we involve y will be 0 plus 6 equal to what? 7. You can just plug it in. All right. All right. Therefore, all right, so this is a rational function. So this function's g of x continues everywhere except what? Continuous everywhere except what? Except x plus y equal to what? 0. That doesn't work. All right, so the only thing this can equal 0 is what? 0, 0. Okay. So the limit show that the functions f of xy, gxy equals to y, and h of x, y equal to c are all continuous. All right, so all polynomial continuous on R2. Let's look at an example here. How do you evaluate this limit? Well, since the right-hand side is a polynomial, therefore it's continuous function. So to evaluate this limit, you simply just plug in what? The function value, the point value there. So you get the answer 11. All right, just as a function of one variable, composition is another way of combining two functions. So similarly, if you have a h of g circle f, then h of xy is just what? G of f of xy is also a continuous function. All right. Two or more variable, right? We're just gonna wave our hand there. Is similarly to the two variables, three or more variables, so we can ignore that. So for example, here you have a function is continuous everywhere except what? Except denominator equal to 0. So when is the denominator equal to 0? It's when this guy equal to 0, meaning this is equal to 1. Obviously, this is a sphere with a radius 1. Okay, so only on that sphere the function is not continuous. It's continuous everywhere else. All right, so that's the end of that.